We have just been through different methods to solve the direct expression of Catalan numbers. In fact, the direct expression of Catalan numbers have a variety of different construction methods. Just on Wikipedia, you will find at least 5 different ways. So why do we say that Catalan numbers are magical? Oh, because they are everywhere. This number can be seen in a variety of problems in our world. For example, we have just introduced the stack and binary trees, as well as the triangulations, and they all correspond to Catalan numbers. In fact, there are more problems. For example, we look at this example. For such a triangulation, we can convert it into a corresponding parenthesizing expression problem. Then this time, we have problem if in our expression we remove all the parentheses, what will happen? Let's see an example. This is a very common example of an expression with addition, subtraction, multiplication, and division. Due to the parentheses, we can easily calculate the result. But if we remove all the parentheses, we will only be left with arithmetic calculation of some numbers. This time, however, semantically, it will have different result. If you do not consider the order of operations and the priorities, then it can get different results depending on the parentheses. This is a big problem. When we are using the computer to conduct a formal proof and verification, and when analyzing the behavior of polynomials, parentheses play a very important role. Then there is a classical problem where we can have an expression, and how many different ways can we parenthesize this expression? Combinations do. In fact, this problem is Catalan number problem. We can use Cn to express the length of a brackets corresponding parentheses of 2n. Of course, this means that we can use these parentheses in other ways. We don't necessarily have to use square brackets or circular brackets. We can even use xy to represent. In fact, this kind of problem has a particular name. It is known as a Dyck word. This is if we use x and y to denote the left and the right parentheses respectively, then we need to find a reasonable way to parenthesize the expression. The other way, it means that we permute x, y. There is a rule. Corresponding to my left is this x. If this has been put, the expression has to end somewhere. Then that is to say, the number of x on the left cannot be less than the number of times y appears, which is basically saying that when we parenthesizing, the right parentheses cannot appear more times than the left ones. So this problem can be still written as a corresponding lattice path problem where it doesn't touch the diagonal. So this problem is very useful in our world of computers. Because there is a formal language, it's known as a Dyck language. It is very interesting formal language in the field of mathematics and computers. It uses different ways of parenthesizing to describe the language. Here we know that this corresponds to this enumeration method of brackets. The number equals to the Catalan number. We have also had a very classic romantic movie with the name Hands Across the Table. Although the name just might be the name of a love story, but it actually is also a very classic combinatorial problem. The problem is, let's imagine, for example, we have n people sitting around a round table having dinner. Then let's imagine a situation where the people greet each other. So if 2 people pairwise want to shake hands, there is a problem. Well, a few people shaking each other's hands, they might cross over some other people, which might create an awkward and embarrassing situation. So we hope that these people sitting around the round table while shaking hands don't cross over any other person. Called the hands cross the table problem. So I ask the question, how many different ways can people shake hands? You may have guessed its answer is also Catalan number. In fact, at the time of beginning of the 20th century, everyone started to look for different types of problems where the corresponding results are all Catalan numbers. But there is a doctorate fellow who in his doctoral thesis found a total of 31 different problems where the results were all Catalan numbers. According to the latest research, as of August 2010, our Professor Stanley listed a total of 190 different kinds of problems where the answers are all Catalan numbers. So Catalan numbers are really magical. that often appears in our world.